examples 29 and 31. So in 29, we're given a first order linear system, but non-homogeneous, as you see right here. And then as a consequence, we're given a solution, a particular solution to this system. And we're asked to verify if this is the particular solution to the system. And I want to show you basically this code over here. How are we going to do it in Matlab? So let's go over to Matlab and let's make some room here. Let's clear all the previous outputs and let's roll with this new problem, exercise 29. Okay, so the first thing I'm going to do is I'm going to clear all previous variables. See, as you can see from your workspace, we do have some variables here. I don't want any of those, so I just write clear all, and those will go away once I execute the code. Then I'm going to define some variables. And what variables do I want to define? But really just t. And then I'm going to define the matrix A. And I'll tell you that to define a matrix, you use any variable, any letter you want. You say equal to, and then you open square brackets, and that is to tell MATLAB that you're going to define a matrix. And then you put the first row, the semicolon to signal that the first row is over, and then the second row. Then I put also semicolon at the end because I don't want this to output over here. I trust that this is correct, the way I input it. Now, what are we going to do? Well, now I'm going to define my solution. So defining the proposed solutions, because we don't know if that solution is right yet because we haven't verified it. So what was the solution? Well, we had the vector 1 and only one entry, so the first row is done. That's why I put a semicolon and 1, and I multiply by exponent t, which means e to the t. This is a function that calls the value e. And now I'm also going to write 1 over, well, sorry, not over, 1 for the first row and negative 1. And I'm going to multiply this times t times the exponent to the t. Again, I don't want this to output, so I put a semicolon at the end. And now I'm going to verify that the solution proposed is valid. And how do you do that? Well, you want to write an equation and see if the left-hand side is equal to the right-hand side once you satisfy the operations on the solutions. And we had an x prime, so we need to take that solution and take the derivative of it, which you do it this way. Diff of that. Then if you wanted to specify the variable, you'd specify with respect to t, and then if you wanted to specify if it's a first derivative, second derivative, you do 1, 2, 3, so on. But since there's only one independent variable, then we can just, MATLAB will just pick it up. And now the equal sign, equality is given by 2 times the equal sign, so equal and equal. And then we're going to write our matrix A multiplied by our solution, which is xp. And then we're going to have minus, remember we had that forcing function, which was a vector, 1 on the first row and negative 7 on the second row, all multiplied by e to the t. And I want this to output, so I won't put a semicolon here. I press Control Enter. MATLAB will execute the commands in this order, and I want to see if the left-hand side is equal to the right-hand side. And we're seeing here that, yeah, this is equal, but is this side equal? Well, it doesn't look like it is. So let's see what we did wrong. Let's see what we did wrong. See, we have a t in here. 2, 1, 3, and 4 is correct. And I think the mistake is here. This is positive. So if I do this, let's see if we get, now this is equal to this, and this is equal to this. So we know that this solution that they gave us satisfies the first order linear system. All right, I hope you learned something, and I'll see you next time.